Welcome, greetings. So in this lecture, I want to talk about the mean value theorem for integrals. I believe this is another one of these theorems that maybe isn't normally covered, but I think that if we're teaching integrals, then this is the kind of thing that may actually be useful, at least conceptually, but maybe also possibly in different circumstances. It's good to know that these things are true. So let's go ahead and go through them. So we're going to say that, so suppose that we have, so here's kind of our setup. We have some kind of function f. Suppose that f is a continuous function. So this is a function f. We want that it's a continuous function on this particular interval. So we suppose we have f. This is a continuous function. And we want this to be true on the interval AB. We like our, try to be consistent here. Let's make this AB like this. Okay. Then we know, so when we're in this situation, then we know that there's going to exist, okay, so then there exists, this is a kind of statement that you're less used to in life, but it's an important kind of statement to get used to. When I'm in this situation, it is possible to find, I'm not telling you what it is, I'm just telling you it's possible to find, then there exists some C, so this is going to be an x value that's going to lie in the interval AB. So satisfying that, and here we go. So we're going to have that f of c I can stand outside of my writing, it's always good. So if we're going to have that f of c. Okay, so c is an input value. It's in my interval. I'm applying my function f to this. This is actually going to equal f average. So we've already learned how to compute that, right? We've learned that that's equal to 1 over, and then we take the length of that interval, b minus a, and then we take the integral from a to b of f of x dx. Okay, so this is the statement of the mean value theorem. Maybe I'll even put a box around it. Oops. Sometimes you got to get creative with your boxes. A Morphe box, okay? So if I'm in the situation where I have a continuous function f on some interval AB, then I will be able to find for you, I don't know what it is, but I will be able to find for you some value in that interval so that when I evaluate at that point, I get the average value of f, which happens to be equal to this, okay? And that can be useful when you don't actually know what's happening the entire time. You're like, at some point I knew you were going this fast. At some point I knew the population was this big. At some point I knew that must have been the cost. Okay, so that's the kind of thing that this can tell you. You might want to know, well, when was that thing? And we'll actually go through that computation in a moment, but first I want to draw the picture for you. Okay, so we're going to have I'm going to draw the picture for you over here because I'm going to change my mind and we'll do the example in the next lecture. So let me just draw the picture over here. So we're going to have A and B. Oops, I forgot to label my axes. I like to label my axes. This is the x-axis and the y-axis. As long as my the functions of x and y, this might also be time. This could be, you know, the number of units of something. Yeah, it can be a lot of different things. That's okay. So this is the graph of my function, y equals f of x. Okay, I know that if I took this here, right? This here is, so you should be used to this by now, this is the integral from a to b of f of x dx. This is the area under the curve. Okay, and then I'm going to have so I have my c is down here. Oops, I'm using red twice. I just don't have enough colors. So my c is going to be down here. Okay, so my c is an x value in that interval. And then what I'm going to have is that, so then I can go up and I can compute f of c. Okay, and so this is like, maybe I'll make it slightly higher so that the picture is slightly less crowded. Okay, so if I go like this, so this is f of c, right? Then I'm going to know, so this would actually be the average value, right? Okay, which was the same thing as taking this integral, right? Okay, so I hope that makes some sense, and then I will see you in the next lecture.